Okay, so our project was a Purdue Transformer, and I am Michael Bittner.
I'm Adar.
And so at the very beginning of the semester, a few of us were together and we were watching the movie Transformers. I'm sure all of you have probably seen it, Shia LaBeouf, Transformers, Aliens, and we thought how cool would it be if we made one of these? What is there out on the market right now and just out in real life? Because obviously there aren't actual Transformers. So we found a few like do-it-yourself like Transformers online. And then we also found a video of a Virginia Tech robot. I guess it's not going to play. But anyway, it's an actual robot and it transforms like on its own. So it's really cool. I guess this video is anyway. So then we were thinking about it, who would we build one of these for? So obviously kids. Okay. And so we figured that kids would definitely want this. And also Purdue fans, because they would also want it. But we knew we need to add like a Purdue flavor. But we weren't sure exactly what we wanted to use as the, I guess, two different forms of it. We could use like a train, the bell tower, Neil Armstrong, or a Purdue Pete. And so we decided that we wanted to combine the train, or the Boilermaker Express, and Purdue Pete. But obviously this wasn't going to be a super easy task because each of them have very different aspects that make them unique. So some of the important aspects of the train are the body, which is this part here, the chimney, so like the smokestack thing, the wheels obviously, and then the buffer at the front. And then similarly with Purdue Pete, we knew that he needed to have all the things of body that an actual person has, like head, body, arms, and legs, and also his hammer.
So I was assigned to make the main body, so I had to work with the others because their parts fit right into my body and helps the transformation. Like here goes the front part of the train and where the buffer connects, and also the legs, and whereas the sides are for the hands, and on the back there's a mechanism for the head to go in and out.
So for the arms, we actually did the upper part of the arm hollow with an opening, so the lower part can rotate and fit inside, saving space. And also the wheels of the train are attached to the arm, as is in the train form. The arm stays hidden behind the wheels.
And the bottom of the train, the front part of the train also work as the legs, which slide in and out the main body.
Also, we needed to make the tunnel, the tower of the train, but we couldn't find a way to make it hidden. So we made it detachable with the hammer inside, so when you take off, the hammer will be inside the tower, so you can place it at the end of it.
And also we had the buffers, which were supposed to be at the very front, and they were really tiny, so they came out to be a bit more flexible than we hoped for.
Yeah, and sort of similarly with the head, it looks so huge when you're catting it, and this was also done with the freestyle modeling in Creo. And it seems really big when you're catting it, and it just looks giant, but then when you actually print it, it's super, super tiny. And so here is a CAD version of the train rendering. And then there is a video on YouTube of the So, sort of all the same things. The kids and the fans. Body, and just more pictures because the arm has 4 different components to it. The legs, the hammer and chimney, buffers, a better picture of the head. And then there's sort of a comparison of the rendering and then what the actual train looks like. And then this is, sure please. Well, there is a transformation in the CAD, and we can show you in a second here the actual. And this is also a comparison of the CAD and the actual render. And then this is like, we got it to sort of transform, but we're going to go ahead and try to do a live. So we can go ahead and this is going to talk about some of like improvements and some of the troubles that we had.
Some of the major issues that we ran into were tolerances and the clearance. When we simulated it, everything seemed to work well and the clearances seemed to be right, but once we printed it, some parts were either too small or sometimes too tight to fit in to each other. We tried sanding them down, but it seemed like it would have been a lot better if we printed them like smoother in the first place. Also, some of the improvements that we have for the future is to make the aesthetics look better, make it look more like Purdue Feet and more like the Bottlemaker Express, the Bottlemaker Special.
Yeah, so that's pretty much the same thing because we're doing like a but the CAD. So you can see the arms sort of push in. They have little slots that were cut into the body, and then similarly with the legs. And so that's sort of a holistic like transformation.
And lastly, we would ideally want it to be, we want to put electronics in it so that it's completely motorized and we don't have to physically use our fingers to push everything in. And also every motion is independent of each other. What we would like to do is to bring them all into like one independent or one system.
And so this head, it rotates and then pushes down into a slot, and the arms fold up and then fold into their slots, and the front of the train pushes back because the legs are really long compared to the front of the train. Hammer. Challenge. All right. And there you go. So now it's in its train. And that's it. Questions?
Okay. Like making it look like Purdue Feet and making it look at the train, make it look like the train, and going through the transition and the transforming phase. I think bringing all those components together was a bit challenging.
Because we sort of had all the features that we wanted to like include, but as you can see, the like body of Purdue Pete and the body of the train don't really look very much alike at all. So it's just very difficult to merge two things that look very dissimilar.
What are the mechanism you used to achieve this transformation? I didn't see very clear the mechanism.
Okay, so we have the head, which it goes in a slot and it moves along the slot and rotates into place. And the head is also on a ball joint, so it can like tilt around.
Like for the arms, they slide out. Like when in the train form, they slide in and lock themselves inside. Well, when in Purdue form, they open up and the arms come out, and the front part of the hand is like a ball socket joint. It's like, so it moves around.
The legs are basically just sliders until they reach a certain point where they can just split apart, and so that they have a greater spread so that the surface area of the feet is a bit larger.